Hello everyone, today we'll talk about the solution to the problem integer to English words. We need to write out the value of the integer in English. So the first thing that we want to do is to decide on a nice representation of those words that we're going to use. I've settled on remembering the numbers of things on 10 position, so on the second position from the right, so the 20, 30, 40. Separately we'll also remember 10, 11, 12, because if the tens digit is 1, then we have to omit emitting the digits digit, the units digit, because it's both within this 12, 13, 14 kind of situation. And also the digits themselves, 0, 1, 2, and so on. So we'll remember them as an array and index into them by 0, 1, 2, 3, and 4, so on. For writing out billion, million, and thousand, since we do it only in a single position, then we'll do it at that position specifically. And of course it's possible to do it iteratively, it's possible to do it more or less recursively. In this case we'll recurse when it comes to finding the number of billions, millions, and thousands, because there can be a couple hundred thousands for instance, so there we'll recurse to figure out that part of 100. And to do that, so for instance for the billions, we'll have to get those digits that tell us how many billions there are in a number. There's nothing more than a couple, well, there's nothing more than some billions, because we are only operating within legal integers. So we just divide by the appropriate value. So here it's 1 with 9 zeros, for millions 1 with 6 zeros, for thousands 1 with 3 zeros, and we take only the 3 digits from it at every position. And we parse those 3 digits separately. We append them to the result and append billion, million, and thousand as necessary. For hundreds, there can only be a single digit of hundreds, so we get that single digit. So first we take only the hundreds digit and take that single digit from it. And now, so the last portion of what remains after we divide by 100, we append it again with the word 100. So here we also recurse. We could also just look up the digit because we know that this is a single digit since we modulo 10. And at the end, the only special case is that, of course, as I mentioned, since the tens digit being 1 means that the last digit is included in the name for that tenth digit, so we just append this. So that would, for instance, be 18. Otherwise, we have to append the tenth digit, of course, if it exists, if it's not 0. And also append the final digit. And of course, for the number being 0, this is the one case where we output something with 0. We just have to make sure that we actually output it at the end, if, for instance, our elements were empty, or if the number just was 0 at the beginning. And at the end we have to get all those parts that we created, separate them with spaces, and return the result. So we just join it with all the elements.